Yes, we're good to go. Hi, so my name is Rebecca. I'm really excited to have you all here. I'm the marketing specialist for Bristlemouth, and I'm really excited to be hosting this panel with Vince Smith from Blue Endeavors, who is part of a new member of the Pioneer Program, Rob McGurrin of BLUEiQ, and they're developing an innovative hydrophone that uses Bristlemouth technology. And finally, Caesar H. Dritton, who's actually joining us online, and he is going to share his Bristlemouth Explorer, which is a software data dashboard developed by community members. So Vincent, after everyone presents, first Vincent will go, and then after everyone presents, I'll open the floor up for live Q&A, and yeah, let's get started. All right. Perfect. All
right. Okay, well, I just wanted to say thank you to everybody behind BristleCon for inviting us to talk. I'm very much excited to be able to share with you our Pioneer project and also the philosophy behind Blue Endeavors and how we got here. I founded Blue Endeavors back in 2012, and it was when I was working with high school students at the time. And what I realized was that they were getting very shut down, frozen in inaction. And when I talked to them, it wasn't that they didn't care about the issues that they were hearing about all the time. It was that they felt that there was really nothing they could do about it. And so they were just, like a lot of people do, tuning out. But at the same time, I was in the field and I was working with a lot of researchers, small NGOs, a lot of great organizations that had solutions. But again, that wasn't what these students, wasn't what the public was hearing about. A lot of the discourse at the time, I'd hear people like Neil deGrasse Tyson saying, with these environmental issues, technology is going to save us. We're just going to put all the smartest people in the room and then they're going to solve the problems. When the reality is it's tens, hundreds of thousands of people coming up with all the solutions to their individual problems and all together solving these issues, right? The smartest people in the room have come up with a lot of the solutions. Some of them are here at BristleCon, right? And it's about how do we really empower those solutions, the next generations, to really make the changes that are necessary. At the time, one of the blockers that we saw was a lot of parallel research happening. It was small NGOs fighting for very scarce resources, grant money. And so when we started Blue Endeavors, it was with a very collaborative mindset. It was coming to a lot of the on-the-ground researchers, a lot of the small NGOs, and saying, how can we advance what you're working on? Can we share ideas? Can we bring technology? Can we crowdsource with research assistants? And then from those impact projects that we found in the world, we started backwards designing curriculum, initially for high school students, but then later on for college students and eventually even middle school students to get involved. And when I talk about students, it's not just domestic students. So we have a hub in the Caribbean, in the Philippines. We have a brand new hub that we're starting in Palau with One Reef. And when we work in these areas, we're coordinating with the local researchers, with the local communities, and especially with the students, so that there's a inclusive aspect to all the work we do, where the students in all these countries and in these frontline communities are working with the students that we bring from programs here in the United States, and they worked collaboratively on these projects. And this is fundamental to the way we work. It's also what we're doing is we're trying to create this new networked era of students around the world coming up with their own projects and sharing in this new world of network community science. So fast forward to 2021, I was introduced to Caesar, who you're going to talk or hear from later on today, and Zach at SOFAR. And we had already been working on a data project that was using community science data. So we were underwater and we were doing indicator species counts. We were using high school students, college students, middle school students to collect these large data sets. It was really exciting about coming and working with SOFAR and Aqualink is now we had open source data buoys that then we could pair environmental data with the underwater data that we were already collecting to advance different projects. Some of those projects, we have one, it was the Manta project, which then we started including sharks with shark stewards. So it's more of an elasmobranch project now. We were able to deploy one of the buoys in Cocos Island, a critical habitat for sharks far off the coast of Costa Rica. We started looking into the efficacy of different coral restoration projects, why some are actually doing really good science, why others are maybe struggling to have results or maybe even having some negative effects in the environment. And then that work brought us to our Pioneer project. So we have been working in Bonaire, setting that up as we're working on a wet lab as well as field experiments. And this is to advance our ability to mitigate coral death during coral bleaching events, also looking at into zooxanthellae. As we were already setting up this project in 2023 in the spring, stony coral tissue loss disease came to Bonaire. And so this is a disease that really decimated many species of corals in Florida, all through the Bahamas, into the Caribbean. And there's a lot that's unknown about it. So this is the first buoy that we're putting out there, is to really facilitate a lot of the research on this disease. And it's not just for the important ecosystem in Bonaire. The idea is to study this disease and stop it before it gets through the Panama Canal and affects corals in the Pacific. So the idea with this is that we're going to be deploying the SOFAR data buoys in strategic locations around Bonaire. And we're going to start by looking at water quality and how that affects the impact of stony coral tissue loss disease, also the spread of the disease. So some thought has been put into perhaps in low water quality environments, this disease is able to spread and have more devastating impact. Although it's also been hypothesized that perhaps the corals that exist in poor water quality are actually more resilient. So there's a lot of fundamental questions we don't know. And this is one of the values of having these large data sets, both environmental data, we really need water quality data, as well as the community scientists, the students are going to be collecting data on algae herbivores in the area to draw a lot of these correlations. So a big need is sensors for water quality, which, as many of you know, are very expensive and in some ways a blocker to a lot of this research. So with our home model, what we're going to do is actually set up workshops to where we're involving the academic community, the student community, to start developing low-cost sensors. And then we could take those sensors and put them alongside the industry sensors that are out here and see if we could get good quality data from significantly lower cost sensors. And this is all using Bristlemouth. That's our Pioneer project. Thank you so much.
Fantastic. Thank you. Hi, how are you all? Okay, great. So I'm Rob McGurrin. I'm from a woman-owned startup in Boston called BLUEiQ, and I'm here today with my co-founder and CEO, Kim Gavin. And we're developing passive acoustic monitoring using software-defined hydrophones. Okay, so how do we get started? So Kim and I were actually at Oceans 2022 last fall, and we saw the viewing of the screening of the movie The Sonic Sea. And it was about how human-generated noise affects whale populations in the ocean. And we were totally blown away by this. We're like, wait a minute, we've got decades of experience developing sensors for sea, space, land, air. There's got to be something we can do to help solve this problem. So we started thinking, okay, so I've got a background in acoustics. We started, well, let's talk about underwater acoustics and understand how can that be used to track, detect, localize whales. We started looking to see, what else existed in that field. And what we found was passive acoustic monitoring has been around for a very long time. The problem is the existing state-of-the-art technology, it's hard to scale, it's expensive, it's hard to make it autonomous. So these are all the opportunities we saw. How do we take our background, our experience, and develop acoustic sensing as an acoustic sensing capability that could scale, that could be persistent, that could be autonomous, and apply that to a number of different marine domain awareness problems in the ocean. For example, how can we prevent whale collisions from vehicles? How can we prevent illegal, unauthorized, unreported fishing? We're also a dual use technology in that we can be used in safety and security applications like tracking, localizing, classifying stuff under the water that shouldn't be there. So we're targeting applications both to protect biodiversity, but also applications for safety and security. Quick note, this is kind of how we came to meet so far. At the same show, we actually saw this woman walking around with one of these buoys. We're like, what is that? That is really cool. So we actually stopped her and asked her, and we learned about SOFAR Spotter. This was Tosca. Tosca's not here today, but that was the beginning of our relationship with Spotter. And we realized, wait a minute, what do you guys use for passive acoustic monitoring on your SOFAR spotters? And the answer was, well, we've tried to do some things, but we really don't have a solution yet for this. And part of the reason is because for a platform like this, it's hard to find anything that's small, power efficient, and cost effective. And we said, okay, this is our opportunity. And that's how we got going. We actually formed in March. And so we've been up and running since March of this year. So what we've developed is a software-defined hydrophone. Actually, got it right here. Pictured there is our prototype. This is actually our prototype integrated into SOFAR's development kit. And so we've developed a very low power processing stack that can do machine learning, advanced signal processing, and do that all within 100 milliwatt per channel power consumption, which is about a 10x improvement over what currently exists. We think this is really important because that low power consumption is really what's going to be able to drive how we're going to scale, get our sensors out into the ocean, especially on small solar powered platforms like the Spotter that has very limited power consumption. So that's kind of like what we've been targeting. How do we get it really small? How do we run machine learning on it? How do we run advanced signal processing applications on it? So how does it work? So you take our sensor and you deploy it on a system like Spotter, and then we basically listen for sounds, and then we run our detection and classification algorithms. And instead of sending raw data back over cellular or satellite, we send detection, localization, or classification information. So we're about data reduction. So we're software defined in that the functionality is defined by what software load you're running on this. So we're not just a recorder. We could be a recorder, but really what we're trying to do is tackle a data reduction problem. And instead of streaming raw data back and processing it in the cloud, do that processing right on our sensor itself. So in a configuration like this, you could have multiple spotters deployed with our sensor on it. It can do detection. We can stream that data back over cellular or Iridium back into a situational awareness display, and then do things like data fusion in the cloud for things like localization if we have multiple buoys. So we started out, developed our prototype, but most recently, just back in September, we launched our prototype that can integrate, our Bristlemouth prototype that can integrate into Bristlemouth. But where we're heading is we want to add more channel capacity, and eventually what you see out in the future is instead of having this sensor, a much more compact sensor with everything integrated, including the electronics to be able to support the Bristlemouth protocol. I'll get the slide control soon by the end of the presentation. So we do have competition, obviously. There are classes of underwater passive acoustic sensors you can buy today, things like data recorders, signal processing units that can process hydrophone data, and smart hydrophones. But really, the thing that's lacking from all these things is the ability to integrate these onto platforms, right? And so that's want to highlight the importance of something like Bristlemouth, an open standard that makes it very easy for us. We're supporting that because that gives us a way to integrate into a platform that's going to allow us to scale and deploy sensors very, very rapidly. Really what's unique about us is that we're multifunction. We can be a data recorder. We can also be a blue North Atlantic right whale detector. We can detect and decode fish tags. So we have all these capabilities running on one unit So we really do reduce a lot of cost by combining all that functionality into one system. So that's I think we really are disrupting the passive acoustic market, and especially with the low power consumption and our flexibility. So we envision ourselves as a company that's going to develop sensors, but we're still trying to figure that out. We've got multiple streams of revenue that are potential, either direct sales, partnering with companies like, for example, Spotter to resell our sensors through them. And also there is an opportunity to license our hardware and software. We have a vision to make our sensor an open architecture. And that's one of our visions is, how can you open this up? You know, Vince, you're talking about like how, you know, it'd be great, especially imagine people having the ability to write applications directly on this to, you know, for monitoring coral reef activity. So that is the vision. And hopefully we'll get there soon. So Kim and I have been working together for a long time. Both of us, between the two of us, we have a lot of product development, executive management experience. But we like to really think ourselves as entrepreneurs and entrepreneurs. We've had a lot of experience developing new programs in large R&D companies for defense and the government, and a lot of experience transitioning to developing technology, transitioning technology, integration and test of that technology, and productization. So far, a lot of accomplishments. We've participated in a number of accelerators. But our big milestones coming up are to complete the integration with Bristlemouth, get this integrated into the spotter, and start our pilot programs, which we're really excited about, you know, getting these systems into the wild and starting to collect and process data. Very excited about that. So next steps for us, you know, we're looking to build our team, complete our MVP, and continue to look for partners and collaborators to work on pilot programs where we can deploy our sensor and start, you know, creating applications. So that's it for me. Thank you. Is there any Q&A now, or do we wait till the end? Wait till the end. Thank you very much.
Thank you, Rob. Okay. Caesar, if you're online, please share your screen at any moment now. And yeah, start your presentation.
Sounds good. My video is off, but I guess that's fine.
Yep, no worries.
No worries. Sounds good. All right, can you see my screen?
Perfect, thank you.
Great, thank you. So hello everyone, my name is Caesar and I'm working with a philanthropic organization called Aqualink. And today I'm calling in all the way from Sweden. Aqualink is working with monitoring for marine ecosystems. And we have developed a tool for people on the front lines of ocean conservation and for people interested in monitoring their local marine environments. Aqualink is open source, free to use, and all the data is public. The Aqualink platform consists of an interactive map, a dashboard, a collection of live streams, a fleet of so far smart mooring buoys, and our newest addition, the Bristlemouth Explorer. Here you can see a screenshot of our interactive map. We have over 700 public sites on this map, and you can explore all the sites by clicking on them and go to the dashboards. As you can see, the sites have different colors. These colors are represented by the heat stress levels that they're currently experiencing. In the bottom of the map, you can see the different heat stress levels. To the bottom right, you can see a list of all the sites we have public, and they are currently filtered by the heat stress levels. To the top right, you can see a preview of the site selected. And in the top right of the map, you can see the layer icon. And if you click on this layer icon, you will be able to see 3 different kind of views. You can see sea surface temperature, heat stress, and sea surface temperature anomaly. And these 3 layers are powered by NOAA satellites data. And as you can see, the sites have different types of icons. The pin drop shape icon is all the normal sites, and these do not have any spotters or loggers connected to them. These sites receive their temperature, wind, and wave data from NOAA satellites. The pentagon shape icon are all the sites that have a SOFAR spotter connected to it. And the logger shape icons are all those sites that have a logger connected to them. For example, a hobo logger. Here is an example of one of our dashboards. And this specific dashboard, and this dashboard, Aqualink dashboards are designed to help you with your monitoring efforts and to provide an instant view of the reef. It's free and you can create as many sites as you want. You can easily add sensors or upload data. On this dashboard, you can see the different dashboard cards. And in the top left, you have the map. Top right, you have a preview of a selected image from the last survey conducted. In the bottom left, you have the temperature data from the NOAA satellites. This specific dashboard has a SOFAR smart mooring attached to it. And in the light blue dashboard card, you can see the temperature and the barometric pressure. The heat stress level alert is coming from the NOAA satellites. And the wind and wave data for this dashboard comes from the SOFAR smart mooring. Below these dashboard cards, you will be able to see graphs of data. And you can also explore the survey they have conducted. You can also attach other things to your dashboards, such as water quality sensors or upload water quality data. If you do that, you'll be able to get one of these green little dashboard cards. You can also improve the dashboard's visitor experience by adding things such as an interactive 3D models of the reef, or as in this case, you can add a live stream. Live stream will also help you get an instant view of your reef's health. To the right, you have one of our users' survey, and this specific user is from Bermuda, and in 2022, they had a heat wave coming through. And in the survey in the bottom of the page, you can see that it represents a few corals that are completely healthy. And this survey was conducted before the heat wave came to Bermuda. The survey in the middle is representing a bleached coral. And this survey was conducted after a heat wave came, after a hurricane came through and passed by Bermuda. And this hurricane cooled down the reef. And as you can see in the top survey, we can see that the coral is slowly starting to recover and that the water is still a little bit cooler. And today this coral is completely healthy. Aqualink also have a collection of live streams. We have 7 worldwide with video feeds. And these video feeds are a combination of live streams and highlights. All of these streams come from Aqualink users who use Aqualink to monitor their reefs. If you want to be able to see all of these streams, you can just visit aqualink.org and then go to highlighted sites. Aqualink has donated over 160 SOFAR smart mooring buoys to organizations worldwide. And one of those examples are Vince that talked earlier today. Some example of what the data is used for is research papers, research projects, and monitoring projects. Most of these buoys are deployed by coral reefs. If you want to learn more about what these data are being used for, you can just go to our website. If you want to be able to see all of these buoys, you can just go to the Aqualink map. And if you look to the right, you'll be able to see this little icon that says deployed buoys only. You can select that one and you'll be able to see all the currently deployed buoys. And you can also visit each and every one of those dashboards. Here is our newest addition to Aqualink, the Bristlemouth Explorer. Aqualink has developed Bristlemouth Explorer, a tool for Bristlemouth users which serves as a dashboard for decoding data. Just like Aqualink, it's freely available and open source. We also welcome external contributions. Bristlemouth Explorer currently allows SOFA spotters connected to a Bristlemouth and an external sensor to decode the data. The goal of the tool is to help developers iterate faster with Bristlemouth, and it will continue to evolve to support the needs of a growing community of Bristlemouth builders. I highly encourage you to try this tool with your Bristlemouth, and please connect with us so that we can continue improving this platform. Lastly, I would like to encourage you to start using Aqualink if you're monitoring marine ecosystems. It's free and easy to create a site, and you'll be able to receive a dashboard with data from NOAA satellites. You can also connect your SOFA spotter, if you have one, to Aqualink. All you need to do is go to aqualink.org, register a site, and edit the site details, and just add your SOFA spotter. Both smart moorings or surface spotters work. Please also reach out to us if you have any external sensors connected to your Bristlemouth you would like to add to your Aqualink dashboard. That's it for me. I hope you try Aqualink and our new Bristlemouth Explorer. And please let me know if you have any questions. Thank you.
Thank you, Caesar. I'll open up the floor for any questions for any of our panelists, if you have any. Any takers? Yeah, go ahead. Wait, 1 second.
Oh, cool.
Whoa.
Okay. Oh. I play soccer, but I can catch. So, okay, for the sensors. So this is interesting to me. I'm a data engineer, and so when you say you're data. Oh, it's a mic.
Mic, yeah. So that Caesar can hear.
Oh, cool. Okay. So I am curious what is the processing that's happening within that system before it goes into the cloud? And like, is there QCing? Because QCing even in the cloud is kind of challenging, and you don't, in our teams, like we don't QC all of our data because there's so much. So what does that look like? And then I think you mentioned it does machine learning, and I wanted to know what that means.
Sure.
Do you mind coming up to the mic to answer?
Yeah.
Great, thank you.
So I guess let me start with the first question. What we've developed initially is for open ear, we've developed a North Atlantic right whale detection using machine learning. So we've developed a process that, let's say we have a customer who wants to put a classifier or detector, machine learning detector on our processor. We have a way to work with them. They can bring them our data. We can build the model from that data and then optimize that model to be able to run on our processor. So,
Wow. So like an object detection model.
Sure. Yeah.
So like a convolutional neural network process.
Yes. Yeah. Yeah.
Wow. Okay.
Yeah. So we're doing that on 100 milliwatts per channel. And we unveiled our North Atlantic right whale detector in September at Oceans 2023.
Yeah. And
Yeah.
what's that accuracy of that model?
So the accuracy of the model is about 90%. So, we're matching, what folks are doing on much larger processing platforms. And so, but part of our sauce is the signal processing and the feature vector that we generate, as well as our model, and then the optimization of that model to run on the processor. So, but that's something as a company, something we provide services we could provide to collaborators. There's a lot of interest in the North Atlantic right whale right now on the East Coast, and not a lot of North Atlantic right whales are going extinct, right? So how do you deploy 10,000 sensors up and down the eastern seaboard in order to track those whales? Right. This is where we're headed. That's why we're trying to do low cost, low power machine learning. But we're not just whales. We can apply our processes to different types of things, acoustic signatures that you're looking to detect or classify.
Okay.
So
Can I follow up real quick on, so like, does the ML go, so if there's 50 sensors?
yeah.
Does the ML go to the cloud at some point? Do they work with each other or
Yeah.
learn from each other?
So we have what we do is we do the hydrophone listens for the data. We run the processing, we run the model on the processor. When we detect, like say a North Atlantic right whale, all we send up is a string, back to the cloud, which is, very little data. It's like location, time, and the classification. So instead of sending all that raw data, we're just doing the classifier right on the processor and sending up a small string, and I can envision in the cloud, if you have multiple sensors, right, you can take that data and fuse it in the cloud to do things like, triangulation, localization.
And then how does that QCing for the data? Could you talk more about
QC,
that?
could you,
The
quality control?
Well, yeah. So usually in like the cloud, right, we run a lot of our data through a QC process. So you have all kinds of raw data, unavailable data, bad data, whatever. So we QC to make sure that if somebody ever wanted to download that, it's actually worth looking at.
Yeah.
Does the sensor do this? Does this ever happen? Is it not integrated yet?
Well, I think a lot of that would be, part of the signal processing that goes on the sensor. I may not understand the question. For example, like the algorithms would have a very low false alert, right? So it's kind of up to the sensor to only generate good quality data. And so we tune those algorithms to make sure like you're only getting 1 or 2 false alerts per day. So you're not flooding, when that data goes to the cloud, there's a very high, it's tuned so you get that high probability of it is what we say it is. So we're trying not to send a lot of data up to the cloud. So I don't know if that fully incorporates.
Interesting.
Okay.
Yeah.
Thank you.
Sorry.
Hi, I was curious. It looks like you're kind of in a proof of concept stage or prototyping, kind of like.
I would say we're just about ready to pilot.
So what's the current cost per unit of that sensor pack, and what's the target?
I would say, if we can maybe talk more offline, if you like. Those are still things that we're working on, and like we want to do a number of targeted pilots to really, figure out what are the user applications that we've got a number of opportunities, and we're trying to focus on, as much learning as we can over the next 6 months with our pilot projects. So.
Hey, I had a question about your presentation. If I understood it right, one of the things you were going to have these miniaturized, and through Bristlemouth, you were going to have an array of them. And I was trying to understand sort of what the benefit is there. Are you doing interferometric techniques, or why do you need an array of hydrophones? And that's actually leading to a more technical question, and maybe this is a question for Evan, does Bristlemouth provide facilities for time tagging and sending accurate time? And how do you, like if you did have an array of things, how do you keep data synchronized at a very precise level?
Sure. So the array capability gives us the ability to localize. So in the roadmap, where we're headed is we first want to do 4 channels, but then we've got technology that allows us to shrink that even further and so we would be going after towed array applications. And this is a couple, like looking into the future, this is the vision. And we've got technology that we've developed to be able to develop, to synchronize, the sensors so you can do array processing at a timestamp that's good enough, locally. But that said, one of the things we want to try with spotters is, if you've got spotter buoys on 1 kilometer or 2 kilometer grids, you're still probably going to be able to get pretty darn good localization given the time syncing capabilities that currently exist. But that's something that we want to try and investigate some more. So, and that, I think, was there another?
Oh, that was it. I assumed that you were doing some sort of processing that required accurate time, and I was sort of curious what facilities existed within, for doing synchronization across multiple buoys.
Gotcha.
So it sounds like, if I understood you correctly, is that there is basic time synchronization already, but that you're looking at more specialized means of doing time synchronization.
If you want to have an array, like a 32 element array with 1 meter spacing,
we should talk a little more offline, but it sounds like I need to talk to Evan a little, maybe first, to understand what the current level of capabilities are.
Sure.
Maybe add a little bit of detail.
Okay.
Spotter gets time from GPS, and then the Bristlemouth moat synchronizes its time to that GPS time from the spotter.
Is that through some sort of like NTP, or
GPS is the time source. I don't know
but
exactly.
how does it get transferred to the moats?
The moat, when it's connected to the spotter,
Yeah.
Automatically receives the fact that there's GPS time available.
Yeah.
So then it synchronizes its clock to that.
And what level of accuracy?
That's an Evan question.
Fair enough.
Okay.
Everybody?
I'm from a other lab in the mission. Been developing a large upwelling device, which is kind of like a big wind turbine in the water for bringing cold, sort of nutrient-rich water to the surface. We had it out, well, this was part of a program on the East Coast. We couldn't actually get permitted to grow seaweed with it because of the North Atlantic right whale. There's effectively a moratorium on doing any sort of permitted sites. One question that we sort of want to get into with it is this is also a platform that we can effectively put a whole lot of instruments on. Current prototypes like 7.5 meter diameter, hangs down 20 or 30 meters, but we can go bigger and smaller. Anyway, it would be very nice to have the ability to obviously detect whales and turn off the system in response to that. And I'm wondering a little bit about, is there a pathway to being able to do localization from one sensor package, or will you always sort of need an array?
Yeah. So as part of that roadmap, that 4 sensor array would at least give us some kind of, bit bearing. I'm kind of going off the cuff here. Haven't really thought a lot about it, but given that, if you're in deep enough water and you can string enough of the acoustic sensors as part of the smart mooring and have enough separation between them, or have two local I think there are things that we could do. Yes, I think that it has to, it's all about how good is your timing and how close are the sensors, and those are really the two driving factors. How well can you synchronize them, and how well do you know their location? And those are the two biggest drivers. But that's kind of the vision, is to be able to do exactly that.
Sorry, I don't want to dominate here. I had one question though about the indicator species, which I thought was a really cool concept, and kind of similar like data modality question. So what type of data is that, and how are students, are they taking photos of indicator species? Are they just like counting numbers? I was just curious what was going on there.
Yeah, we've tried to align with PSCO, which sets a lot of the standards that like UC Santa Cruz, Stanford, a lot of the AAUS facilities use. So that way, because one of the big things when you're trying to collect data that you're putting out to the community, we're trying to answer questions that haven't even been asked yet. We want to figure out what's the standardization for collecting indicator species data. So we're aligning with a lot of the university research protocols, as well as some of the community science organizations out there, like REEF is worldwide. And so we want to make sure that if we're collecting data for everyone, that we're also including their protocols as well. And because we are training our own community scientists and students, we have different levels of how valuable that data is going to be. Obviously recognizing that, the first time a high school student goes out there, their data is not going to be very valuable. But as they progress through a scientific diving curriculum, and we could get validation and inter-rater reliability, we could really validate that data and have it be more useful. So that way, whatever organization's using the data, they'll know how it was collected and in line with their protocols. And then some of the work, like when we talked about in Bonaire, Stanapa is really the organization that is doing most of the research. And so they have their own protocols as well. So we'll integrate those for our community scientists. I think one of the things we're looking at is worldwide, we need a lot more standardization on a lot of these protocols as community science is starting to crowdsource more of this data collection. I mean, one of the things we're really pushing for is, can we get as a global community more standardization so that the methodologies are the same to make that data more valuable? and hopefully, again, with Aqualink being available to everyone, we can start publishing our methodologies and trying to sync up with other organizations. Oh, yeah.
My question's about the curriculum. So, and for example, in a high school, we've got an initiative underway to try to get marine tech being used in the science classroom, and we're piloting with a environmental studies class. Where are you getting your science class curriculum?
That's what the educational component of Blue Endeavors does. So we developed that curriculum, and we've really set these up as workshops. So the idea is that, a lot like a university. So the idea is that in these workshops, we're able to ask big questions, fail quickly, rapid prototyping, explore these crazy ideas in this setting. And then from that, some of these ideas will then maybe really do have some proof of concept, and we'll start growing them, validating them. And the idea is that's what we consider more of a scale up project. So then that's when we'll bring it more to the professionals. And after almost 11 years of doing this, some of our projects have grown significantly. And so we're actually starting a venture studio where we have some partners involved, where we're pairing financial mechanisms on one of our projects. It's a parametric insurance product to start scaling these projects that have proof of concept to the world. So our curriculum's always set up at the earlier levels as very experiential, place-based, hands-on, and in a workshop setting. So yeah, if you want to know more, please, we'll talk. Yeah.